The logic which we have used for the permutation, the same we are using, but the thing is you have to divide it here by r factorial. So what do you mean by combination? We are going to choose r number of objects from n number of objects. So whenever you have a large number of things to multiply or divide, you can just change the formula in this way so that it will become simple. N number of parallel lines, then the formula will be MC2 into NC2. Hello everyone, welcome to One and All. This is your Shruti ma'am, Vidhyaashram PU College, the Temple of Excellence, Mysore. So welcome to the 6th session of Permutations and Combinations. So in the previous session, we have discussed about the circular permutation. So what do you mean by circular permutation? So any number of people, books or anything which are arranged in a circular way. Okay. So there we consider the permutation as circular. So what is the number of arrangement in circular permutation? So we will take it as n minus 1 factorial. Why n minus 1 factorial? Because every 4 arrangements in circular permutation is considered as one arrangement. So therefore it will be always 1 less than compared to the linear permutation. Also we have learnt one more formula when it is in the case of necklace or garland. The formula of the circular permutation will be n minus 1 factorial divided by 2. Why? Because here the clockwise and anti-clockwise is not distinguishable. They are considered as the same. So in this session, we will be learning about combination. So we are learned what do you mean by permutations, type of permutation and also circular permutation. So today I'll start with the combinations. So what do you mean by combinations? So we have already learned about permutation, that is arrangements of things, books or people in an ordered way. Okay, so combination is nothing but choosing the things. So here order does not matter. Okay, so the order of the arrangements of the objects will not matter in terms of combination. So now let us learn directly the formula for the combinations. So in this session, we will be learning about the combination, its properties, also some simple problems for your examinations. Okay, so now let us study what do you mean by combination. So directly we'll go to the formula of the combination. Okay, so what is the formula for the permutation? N P R is n factorial divided by n minus r factorial. So this is the formula for permutation, remember. So what combination? So the combination of n distinct objects taken r at a time is given by NCR is equal to n factorial divided by n minus r factorial into r factorial. Why we have divided r factorial here? Because the order doesn't matter. Okay, so the arrangements is taken as same in terms of combination. So here the order doesn't matter. That's why we have divided by r factorial. So now they have given you n distinct object taken r at a time. So how we will simplify using the combination formula? So let me take an example, 10C3. So how we are going to write 10C3? We write it as 10 factorial divided by given n minus r. So n means 10, r means 3. So 10 minus 3 is 7 factorial over r factorial again, that is 3 factorial. So how we will solve? You are going to solve in like this, 10 into 9 into 8, 7, 6, 5, 4, 3, 2, 1 over 7, 6, 5, 4, 3, 2, 1. Again 3 factorial, 3 into 2 into 1. So how we will cancel? Like this. Again we have to cancel 3 1s are, 3 3s are, 2 1s are, 2 4s are. So that is 120. 20. 10C3 is considered as 20. So this is a very complicated method because we have to write all the terms and we have to cancel it one by one. The logic we have applied for the permutation is like if you take 10P3. So just write the 3 factors from 10 for permutation. So that is 10 into 9 into 8. So in the similar way, I'll apply the same logic for 10C3. Okay, suppose you have taken it as 10C3. Okay, write the first 3 factors from 10, that is 10, 9, 8 and divide by 3 factorial, that is 3 into 2 into 1. See, this is one and the same. Lastly, we are left with this. Then we again cancelled and we have written it as 120. So this is very simple way you can use for the calculation. So you can leave the rest of the numbers and write it directly. Suppose you have written 5C2. Okay, then just write 2 numbers, that is 5 and 4. Then divide it by 2 factorial, that is 2 into 1. Okay, which is nothing but 10. So the logic which we have used for the permutation, the same we are using, but the thing is you have to divide it here by r factorial. Whereas in permutation we will not divide, we will just write the number of factors. Okay. So next we will study some properties of the combination. So without proof, why without proof? This is not in your syllabus. That is the proof of the properties of the combination is not in the syllabus. Just learn them because it will help you for solving the problem. The very first property here is NCR is equal to NPR divided by R factorial. So this is giving the relation between, so this is relation between permutation and combination. Okay, so let me check how it comes. What is my formula for NCR? NCR is equal to n factorial by n minus r factorial by r factorial. What is this actually? This is my formula for permutation. Just replace it. So NCR is equal to NPR by r factorial. Or I can write this as NPR divided by NCR is equal to r factorial. This is another form of relation between permutation and combination. So listen here, since n factorial by n minus r factorial can be taken as NPR, just replace it. So this formula can be written in 2 ways, either in this way or in this way. Okay. So let me go to the second property, that is NCN. Okay. NCN is equal to NC0 is equal to 1. What do you mean by NCN? So what do you mean by combination? We are going to choose R number of objects from N number of objects. So what is here? We are choosing all the objects. So choosing all the objects can happen only one time. Choosing 0 objects can also happen in one time. So if we apply the proof here, NPR in NCR formula, so we know NCN means n factorial by n minus n factorial into n factorial. So n factorial get cancelled. N minus n is nothing but 0. We have agreed that 0 factorial is always 1. So this is equal to 1. So therefore NCN is equal to 1. Similarly, you put NC0. So NC0 is nothing but n factorial, n minus 0 factorial divided by 0 factorial. Okay. So here also n factorial, n minus 0 is again n factorial, cancel. 0 factorial is nothing but, so my answer will be 1. Just remember, this is very simple thing. Wherever you find NCN, you can directly write 1. Wherever you can find NC0, you can directly 1. For example, if you have 7C7, you can directly write it as 1. Or 5C0, you can directly write it as 1. So no need to calculate, you just remember the property and directly write the answer. Next is NC, n minus 1 is n and NC1 is also 1. So let me go for the third property. NC, n minus 1 is equal to n, which is also equal to NC1. So let me take an example now. 7C, 7 minus 1. Okay, just in the place of n, I have taken 7. What I should get? 7 only. So let me check, will I get 7 or not? Okay, so 7 minus 1 means 6. So how we will write? 6 factorials of 7, that is 7 into 6 into 5 into 4 into 3 into 2 into 1 over. So 6 into 5 into 4 into 3 into 2 into 1. Just cancel this. So you will write 7. So you are getting the same 7. So whenever you have this form, okay, for example, 8C7, you can write it as 8. Okay, so 10C9, you can write it as 10 directly. So just one number less than n. Just one number less than n, you can directly write it as n. Similarly, you can prove this also. The proof is not in the syllabus as I said before. Next we have NC n minus r is equal to NCR. Let me take an example now. We have 10C7. So choosing 7 factors from the 10 factorial. So that is 10 into 9 into 8, 7, 6, 5, 4. So all the 7 factors we have written divided by 7 factorial, that is 7, 6, 5, 4, 3, 2, 1. So it is very large process, that is you should divide all the numbers. Okay. So whenever you have these kind of problem, you can just replace it like this in this form. Okay. That is you can write this as 10C 10 minus 7. See, when you have n, r, just replace this by n minus r. So what happens? This is same as 10C3. Just choose the 3 factor, 10 into 9 into 8 over 3 into 2 into 1. Just cancel it. Okay. So you will get the answer which is 120. See, very simple. So whenever you have a large number of things to multiply or divide, you can just change the formula in this way so that it will become simple. So you can write NC n minus r as NCR or NCR as NC minus NC n minus r. Next property. If NCR is equal to NCK, then either R is equal to K or R plus K is equal to N. So in my previous example, so we have taken 10C7 is same as 10C3. Look here, 10C7 is also 120, 10C3 is also 120. But here, R is different. So 10C7 is same as 10C3. But R is different here. So here R is 7 and here R is 3. But what about N here? See, N is 7 plus 3, that is 10. So whenever you have two combinations, the formula of two combinations are equal, one thing is R must be equal, or the other thing is N is the sum of the two R's, that is R plus R. Here I have taken 7 plus 3 is equal to 10. Next, this is also one more property. N plus 1 CR is equal to NCR plus NCR minus 1. So here, this is N plus 1. So here 1 less than N plus 1, that is N. What about R? R minus. These are two consecutive numbers. These are two consecutive numbers. If you have 7 here, then it must be 6. Okay. So if you have 10 here, then it must be 9. Remember. Okay. So 10 NCR plus NCR minus 1 can be written as N plus 1 CR. So the properties is of equality. So you should remember from left hand side to our right hand side, from right hand side to left hand side also. Next, 2 power n can be expressed in the series of combination. Okay, 2 power n. The powers of 2 can be expressed in terms of combination as NC0, n plus 1 to NCn. And 2 power n minus 1. Whatever number you will get in terms of 2 power 1, that will be an even number. Minus 1 will give you the odd number. So that series can be expressed in this form, NC1 plus NC2. So the only difference is here you have NC0, here you don't have NC0, you should start from the series NC1. So these are the properties of the combinations. They are very, very useful while solving the problems. Next, we will learn some important formula. Whenever you are going to calculate the problems in combinations, these formulas are useful for geometrical figures. Okay. If there are n points in a plane out of which k points are collinear, the number of straight lines that can be formed is nc2 minus kc2 plus 1. So what are the minimum number of points required to draw a straight line? It is 2. Correct? So to draw a straight line, you need 2 points. Suppose you have many points like this. Okay, so you have a point like this. So if I draw a line here, so you have points here also. How many number of points you have? You will consider it as a single straight line only. You will not consider it has this is 1 line, 2 line, 3 line, 4 line. Okay, so there are number of points which are collinear. Okay, so when you have a collinear points, so the number of straight lines formed this one. NC2 minus KC2. What this K represent? K represent how many points are collinear. So you have to subtract the points which are collinear. So therefore the formula will be equal to NC2. Why NC2? Because out of n points, I need only 2 points to draw a line. Okay. So and K points are collinear that I have to remove, because I will not consider them as different line. So therefore the formula will be NC2 minus KC2 plus 1. What about triangles here? So line is over triangle. So how many points we need to draw a triangle? I need 3 points to draw a triangle. See, 3 vertices. Any 3 vertices which are non-collinear. Okay, if the points are on the same line, then I cannot draw a triangle. So there must be a non-collinear points. Suppose you have a collinear points like this. See, and you have a triangle. So you will form a triangle. When you draw, this is also a triangle, but here you have more points which are collinear. So therefore, there also you have to remove the collinear points. The number of points required to draw a triangle is 3. Therefore, the formula is NC3 minus KC3. Next case. If there are n points in a plane, no 3 points are collinear. Okay, no points are collinear in the plane, then the formula is just NC2 for straight line and NC3 for triangle. No need to subtract any collinear points because no 2 points or no 3 points are collinear there. So therefore, the formula is very simple. That is NC2 for straight lines and NC3 for triangles. Remember these formulas while solving the problems. Next. Number of rectangles or parallelogram when M parallel line intersect N parallel line. I'll take C, which is MC2, NC2. Okay, so I'll just take 3 lines here, 3 parallel lines and 2 parallel lines. Okay, so how many triangles I can form? Firstly, 3 set of parallel lines I have taken. So it is 3C2 I'll take. Next here, 2 set of parallel lines I have taken. 2C2. Remember the formulas for this. NC, N minus R. See here. So NC, N minus 1 can be written as N and NC1 is also N. Okay. Then NC, N and NC0 is 1. So when you have N and R same, it is 1. Okay. So therefore this is in the form of NC, N minus 1, that will be equal to N. So this one I can directly write it as 3 and this is 2C2. So NCN is always 1. So therefore it is 1. So there must be 3 rectangles or 3 parallelograms. Okay. So now let me check. So this is one rectangle. This is one rectangle and the total. This is one rectangle or you can take it as a parallelogram. So the smaller 2 and the bigger one is 1. So 1 plus 2 is 3 rectangles or 3 parallelograms. Like this, when m number of parallel lines intersect n number of parallel lines, then the formula will be MC2 into NC2. So next question, number of diagonals that can be formed by joining the vertices of a polygon of n side is n into n minus 3 by 2. So just remember this. So you have to remember all those properties and formula, but the proof is not in the syllabus. Just learn them as it is. Okay, so let me check this now. We have n into n minus 3 by 2. Let me draw a pentagon here. So we need 5 vertices. Okay, so here. So according to the formula, n is nothing but number of vertices of a polygon. So here our n is equal to 5. So what is n into n minus 3 by 2? That is 5 into 5 minus 3 is 2 by 2. So that is 5 triangles can be possible according to the formula in using pentagon. So let me check this. So this is one triangle. Okay, 1, and this is 2, this is 3. So you check it. So you will be getting 5 triangles here. So this will be the outside part of the pentagon. So you can draw and check. You will get 5 triangles. So therefore, the number of diagonals for n vertices is n into n minus 3 by 2. Remember this. Next one. Number of triangles that can be formed by joining the vertices of polygon. My next property is, so number of diagonals. So number of diagonals that can be formed by joining the vertices of a polygon of n sides. So you have n sides, that will be equal to n into n minus 3 by 2. Let me take an example. So I'll draw a pentagon here. So pentagon has 5 vertices. So therefore here my n is equal to 5. Therefore my n is equal to 5. So let me verify this in the formula. How many diagonals I can get? So that is 5 into 5 minus 3 divided by 2, which is 5 into 2 by 2, which is 5. So I should get 5 diagonals. Let me check here. So now 1, 2, 3, then where I can join 4, 5. So I will be getting 5 diagonals. 1, 2, so this is 3, 4, 5. So you will be having 5 diagonals. So for all the polygons you can check. So this is the general formula we use to count the number of diagonals in an n-sided polygon. My next property. Number of triangles that can be formed by joining the vertices of polygon of n side is NC3. Okay, so when you have a n-sided polygon, for example, in a pentagon, so you can, how many triangles you can form by joining the vertices? So just see here like this, you can draw one triangle, then you can draw one more triangle like this, then you can draw one more like that. In the similar way, you can draw. So how many triangles you can draw? That is NC3. Suppose in a pentagon, it is 5C3. Okay. So in a pentagon, it is 5C3 because you have 5 vertices in a pentagon. So therefore, it is 5C3. What will be my answer? 5 into 4 into 3 over 3 into 2 into 1. So 3 cancels, 2. So you can draw 10 triangles inside the polygon, that is inside the pentagon. Similarly, how many quadrilaterals? Quadrilaterals means it should require 4 vertices. So therefore, the number of quadrilaterals you can draw inside the polygon is NC4. So these are the very important formulas you should remember while working out the problems. Next, let us take few simple problems on combinations. Problem number 1 if NC4 is equal to NC5, find N. So previously my property I have said that if you have NCR is equal to NCK, so either R must be equal to K or my N is equal to R plus K. So this is the property we have learnt. So find N they have given. So therefore what will be my N? N is equal to 4 plus 5, that is equal to 9. These are for 1 marks question, very simple. Next question, find N if NC10 is equal to NC15. The same property we are applying here. So N can be directly written as 10 plus 15, that is equal to 25. So remember the properties. Next, find X if 99C40 plus 99CX is equal to 100C59. So remember this property, that is N plus 1 CR is equal to NCR plus NCR minus 1. So here this is of this form. Okay, so this is of this form. So you can clearly see here. And also remember one more property, that is NCN minus R is nothing but NCR. NCN minus R is nothing but NCR. So this one I'll change it to 99C99 minus 40. Because we have learned the properties, that is N minus R is same as NR. Okay, so therefore plus 99CX is equal to 100C59. Okay, so now write this 99C59 plus 99CX, so is equal to 100C59. So you can clearly observe the formula here. So in the place of N plus 1 you have 100. So N plus 1 you have 100, and in the place of R you have 59. R you have 59 and R minus 1 is equal to X. What I need to find? X. What is my X? X is equal to R minus 1. What is my R? My R is equal to 59. Since R is equal to 59, substitute here, it is 59 minus 1 is equal to 58. I already said you that in this formula, R and R minus 1 are consecutive integers. So therefore, when it is 59, this must be 58. Next question. Find X if NCX plus NC7 is equal to 10C7. The same formula we are applying it here. N plus 1 CR is equal to NCR plus NCR minus 1. So in the place of N plus 1, you have 10. In the place of R, you have 7. Okay. So therefore, this one you take it as R minus 1. Just they have rearranged the places. Order is changed, but the sum is same. So therefore, here also X is equal to R minus 1. Whereas R is equal to 7 here. Since my R is 7, so what happens here? X is equal to 7 minus 1. Therefore, X is equal to 6. Next question. If NPR is equal to 30,240, NCR is equal to 252, find R. So remember the formula. NCR is NPR divided by R factorial. So this is what we have learned. So this can also be written as NPR divided by NCR is equal to R factorial. So I will use this one now. So let me take NPR by NCR. So we know the relation between permutation and combination. That is what? 30,240 is equal to 252. That must be equal to R factorial. So when I cancel this, I'll get it as 120. You can verify. So r factorial. How 120 can be written? So how 120 can be written? So you can use by inspection method also, or you can use by dividing it also. So therefore, this can be written as 5 factorial, because 120 can be written as 5 into 4 into 3 into 2 into 1. So you check, 5 4s are 20, 23s are 60, 62s are 120, into 1 is 120. So therefore 120 is the product of first 5 consecutive integer. Therefore it is 5 factorial, which is equal to r factorial. Just remove the factorial. So therefore what is my r? R is equal to 5. So next question. If NC8 is equal to NC12, find NC5. My aim is to find NC5, but before that I should find the value for N. So we know that when NCR is equal to NCK, that implies N is equal to R plus K. So property. So therefore, my N is equal to 8 plus 12. This is equal to 20. Now we have to find NC5. So we know the value of N is 20. So it is 20C5. So how we will write? Just write the factors here. 20 into 5 factors of 20 factorial. 20 into 19 into 18 into 17 into 16. Whole divided by 5, 4, 3, 2, 1. So therefore, you will get 15,504. Next question. If NP5 is equal to 24 into NC4, find N. So just remember the formula of NP5 and NCR, and remember the factorial also. So N factorial can be written as N into N minus 1 factorial, or N into N minus 1 into N minus 2 factorial. So like that. So for example, 7 factorial can be written as 6 into 5 factorial, which is one and the same, or 6 into 5 into 4 factorial, which is one and the same. So this concept I am using here. So we have NP5. So what is the formula for permutation? N factorial by N minus R factorial. So therefore this can be written as N factorial by N minus 5 factorial. So we have 24. Again, what is NC4? NC4 is N factorial by N minus 4 factorial divided by 4 factorial. Okay, so you can clearly see on RHS and LHS, N factorial get cancels. What is 4 factorial? 4 factorial is 24. 4 into 3 into 2 into 1, which is 24. So therefore, 4 factorial and 24 also get cancels. So here we have N minus 4 factorial. Here we have N minus 5 factorial. So you can observe here, I'll write N minus 5 factorial as N minus 5 into N minus 4 factorial. So my next problem is NP5 is equal to 24 into NC4. Find N. So I'll use the concept of factorial here. Remember, N factorial can be written as N into N minus 1 factorial. Or you can write N minus 1, N minus 2 factorial also. For example, 7 factorial I'll take. 7 factorial can be written as 7 into 6 factorial. Or you can write it as 7 into 6 into 5 factorial, which is one and the same. The same concept I am using here. So what is my NP5? Use the formula of permutation. That is N factorial by N minus 5 factorial. Next I have 24. So what is this? N factorial by N minus 4 factorial into 4 factorial. See here, this can be written as N into N minus 1, N minus 2, N minus 3, N minus 4, N minus 5 factorial, which is one and the same. So N minus 5 factorial. or you can simply write till n minus 4 because we have a factor n minus 5 which will get cancels. So this here, this is equal to 24 into, here also I can write it as n minus 1, n minus 2, n minus 3, n minus 4 factorial divided by n minus 4 factorial into 4 factorial. Okay, I can cancel n minus 5 factorial, n minus 5 factorial here. Here I can cancel n minus 4 factorial, n minus 4 factorial. 24 I cancel with 4 factorial. Why? Because 4 factorial is 4 into 3 into 2 into 1, which is 24 only. So what I have left with? I have left with n minus 1, n minus 2, n minus 3, n minus 4. Here n minus 1, n minus 2, n minus 3. The same thing I can cancel n minus 1, n minus 2, n minus 3. n minus 1, n minus 2, n minus 3 get cancels. So what I have left with? I have left with n minus 4. All the things on the right hand side cancel. So it is equal to 1. So just shift this 4 that side. It is 1 plus 4, which is equal to 5. So my value of n is 5. Okay. So next question. If NPR is equal to 240, NCR is equal to 120, find N and R. So simple formula, we know NPR by NCR is equal to R factorial. So therefore here 240 by 120 is equal to R factorial. What this implies? So 2. So my R factorial is 2 factorial. 2 into 1 is nothing but 2 factorial. So therefore my R is 2 here. So now let me find N. Let me consider in this form. So we have to find NC2. We have to find NC2. So already we have NP4 is equal to 240 and NCR is equal to 240. So since I don't know the value of N, either I can choose NC2 or I can choose NP2. Substitute in any one of the arrangement, you will get the value of N. So let me take NPR. NPR is equal to 240. So N I don't know. So R is 2. That is 240. This I can write it as N factorial by N minus 2 factorial into 240. Until N minus 2 factorial, if I get cancelled, I am left with N into N minus 1 is equal to 240. So N square minus N, shift this 240 here, it becomes minus 240, that is equal to 0. So we have to use the quadratic formula. We have to use the quadratic formula. So let me see here, N square minus 20N plus 17N minus 240 is equal to 0. So we got N square minus N minus 240 is equal to 0. So here I have to use the concept of quadratic formula. So either you can use the formula or you can use the splitting middle term. Okay, so I'll use the splitting of the middle term. So N square minus 16N plus 15N minus 240 is equal to 0. So how I have written 16 and 15? So split 240. When you multiply, you should get 240. And when you add, you should get the middle term. So here the middle term is minus 1. So therefore, minus 16 plus 15, you will get minus 1. And when you multiply, you will get minus 240. So after solving, I'll get this as N minus 16 and N plus 15 is equal to 0. So what is my option? N is equal to 16 or N is equal to minus 15. Since N cannot be negative, okay, N cannot be negative. Why? Because arrangements are counted. So counting numbers are natural numbers. So therefore, my value of N is 16. So therefore, what is the value of N? N is equal to 16. So what we have done here, so we are supposed to find both N and R. So using the relation between permutation and combination, just find the value of R. After finding the value of R, use the value of R in either permutation formula or combination formula. Here I have used the formula of permutation. You can verify it using NCR formula also. The result will be same. So your value of N for this is 16. So in today's chapter, we have learnt about the combinations, the properties of combination, and some important formulas about the geometrical figures using combinations. So remember this, it is very, very important while solving the problems. So properties and formula, it will be very helpful, it will save our time. So just learn them. The proof is not there in your syllabus. So only just learn the properties and whatever the formula which you have in the combination. So I hope you understand today's session. So thank you. So till then, take care. Keep watching, keep learning, and keep exploring. Thank you.